Alright, in this video I want to show you and kind of answer this question with a proof as to why is the derivative of sine equal to cosine. Alright, and you can do the same exact proof or a very similar one once I show you how this works for why is the derivative of cosine equal to negative sine. So you can do the same thing if you wanted to, try a different proof here. But a couple of things I want to point out first of all, and that is there are a couple of useful limits. Let me slide this down so you can see it, that we're going to need, as well as some addition formulas for trigonometry. But anyways, here are the useful limits that we're going to need. The first one being is for sine of x over x, where the argument for sine is the exact same as the denominator, the limit as x goes to 0 is equal to a 1. Right? The limit is equal to 1. This is also another limit that we're going to use as x approaches 0 for cosine x minus 1 all over x. That limit is equal to 0. So we're going to need these two useful limits. All right, so keep those in mind. As well as we're going to need some trig addition formulas. Well, it turns out that for proving why sine is equal to cosine, the derivative rather of sine is equal to cosine, we're just going to need this first addition formula for sine. You can use the second one here for cosine if you wanted to prove why the derivative of cosine is equal to negative sine. Alright, so you can use the second one later if you'd like. Alright, so armed with those things, here goes. Let's figure out why the derivative of sine is equal to cosine. Well, let me start with our difference quotient. Alright, and I'll use h instead of x. There we go. We'll use h. Right. So the limit as h approaches 0 for f of x plus h minus f of x. Right, this is the one that I usually show how a derivative works as far as limits are concerned. Right? And obviously I cannot plug in 0 for h right now because that would make my denominator 0. But let's go off and find out, right, assuming that that sine x is our f of x function. Let's go off and find out. So let me just do this here real quick. This is our f of x. Right? Sine x is our f of x. Let's go find f of x plus h. Okay, so that's the first thing I'm going to go do, and that's pretty easy to see. F of x plus h. If f of x is equal to sine x, well, I'm just simply sticking in x plus h everywhere I see an x. So it just looks like this. Okay? But that's where I said a moment ago that we're going to need this trig addition formula, right? Because look, I have the sine of two angles being added together is equal to sine of alpha cosine beta. So sine of the first angle times cosine of the second angle plus cosine of the first angle times the sine of the second angle. So we're going to need that here, but instead of alpha and beta, I've got x plus h. So let me rewrite this here. I've got the sine of x times the cosine of h plus the cosine of x times the sine of h. Alright, so that's what my f of x is equal to. And I think I've got all the players now. I can use this limit, difference quotient limit here. Alright, so here's what I've got. I've got the limit as h approaches 0 for my f of x, right? My f of x, which is now this. Alright, so I've got sine x cosine h plus cosine x sine h. Okay, and then minus my f of x. Well, my f of x was just simply the sine function. So minus sine x. And this is all over h. So I'm going to pull some algebra tricks and also use those useful limits that I just showed you a little bit earlier here. Let's see. Do you see? Look at this here. This is a little algebra here. Do you see this term and this term both have a sine x in it? And if we were to factor that out, let me scoot this over here. If we were to factor that out, this is what we'd have. We'd have sine x. Right? And if I took a sine x out of this term, I'm left with cosine h. And if I take a sine x out of this negative sine x term over here, I'm just left with minus 1. Okay, and this term up top in the numerator that I didn't touch so far, well, it's still there. It's still as plus cosine x sine h. Okay, so this is still all over h. And don't forget our limit is out here. Okay, so I'm running out of room. Let me switch over to another sheet, but this is what we have so far. But I want you to recognize a couple of things. All right, I want you to recognize a couple of things. And the other thing too that I'm going to do is, look, I've got two terms up top. I've got this term here, and I have this term here. And since these two terms, separated by this plus sign here, are all over h, I can rewrite them as h, or I can rewrite them as separate fractions where h is my common denominator. So I can go from this, let's see if I can keep this on here so you can see it. All right, I can go from this here to this. Let's see if this makes sense to you. As h approaches 0, so I'm going to write this as one fraction. I've got sine x, and in parentheses cosine h minus 1 all over h. So there's one fraction. Okay, and now let's take this other fraction over here, which is cosine x sine h all over h. Now, why am I writing them out as two separate fractions? Well, I want you to recognize something now, all right? I want you to recognize something. Do you recognize this right here? Let's see, do you recognize this right here that I'm going to circle in blue? Do you see that that is really, right, that is really the same thing as this limit right here? All right, instead of x's, though, I've got h's. But still, as x approaches 0, or as h approaches 0, this bubble that I just put in blue here is really just a 0, right? It's just a 0. That's what that limit is. So sine times 0, well, this whole term turns into a 0. It really just goes away completely. Okay? Do you recognize something else over here as well? Do you recognize that, and I'll do it in blue again, do you recognize that sine h over h as h approaches 0? Hey, that's very similar to this other useful limit that I have here, right? Instead of x's, though, instead of x's, I've got h's. But it's the same thing. So this whole blue bubble turns into a 1. Right? So this one here turned into a 1, whereas that limit over there turned into a 0. And what's 1 times anything? It's just itself. So here's what I've got. I've got the limit as h approaches 0 of cosine x. That's the only thing that remained out of all of this stuff. Well, I have no place to plug in 0 for h because there is no h in this function. So it's really acting as a constant, and my final answer is cosine x. So there's an analytical proof as to why the derivative of sine is equal to cosine.